Hello, dear students. This is my first online lecture. Remember, I hope all of you are safe first of all. This is my first online lecture for our courses 03102, Principles of Agricultural Economics. I'm going to go quickly through chapter 4 PowerPoint. I know that I'm going to skip some of the slides because I already covered that in our class before. But remember, please, that you need to, in addition to the chapter 4 PowerPoint, you have to look at my Word document, two Word documents. One of them is Shireen 7, Shireen _7, and one of them is Shireen _8. One of them talks about production theory in general, and the other one talks about the production function. Okay, this is the first slide. Remember, we talked about that in our class, about the definition of production, and we said that production is a process of transforming inputs to outputs. And by definition, when you do that, you have to have a certain level of technology. We assume in the short run that technology level is constant anyway. And remember, all of our analysis, inshallah, throughout the course assumes short run conditions, which means that the producer can only change the amounts of some inputs, not all of them, because he doesn't have or she doesn't have the time to do that. Okay, and remember when we said that we can produce intermediate goods, we can produce final goods, we can produce anything from raw materials and up. And we said before that the economic problem, it's about we have scarce resources in general. These scarce resources have so many alternative uses, and as a result we need to economize. Economize, it means that we cannot afford to waste these resources. And remember, these are the questions that are addressed in production theory: what to produce, how much to produce, how to produce, when to produce, and for whom to produce. These are the questions that are addressed by any economy, by any society, by any community, in order to decide what the people need in a certain country. And we defined that before. Remember, we said that we have 4 factors of production: land, labor, capital, and management. Land, this is planet Earth, all the way from the magma to the ozone layer. And the reward for using land resources is called rent. This is a terminology that we use in economics. Okay, this is the amount of money that you receive if you utilize land resources in production processes. Labor, again, is the other factor of production, and we said that the reward for using labor is wage. Okay, why do you work? To earn wage. And the capital, this is actually, it's called the machinery, equipment, and building. It is any man-made thing, and the reward for using the machinery, equipment, and building is called interest. So this is a type of money that you receive when you use capital. Management, this is another name for that, is called entrepreneurship. I said that before. And these are the people who organize and manage businesses and assuming risk. Because in order to manage, in order to become an entrepreneur, which is a businessman or a businesswoman or a business person, you have to assume risk. Because what does it mean to assume risk? You have to accept risk. Because there is risk whether you like it or not. And the reward that you will get if you become an entrepreneur is that you earn what is known as profit. Profit is a type of money that you will get if you become an entrepreneur. And here we said that in production theory, remember we said that we can produce different quantities using the same amount of resources, which means simply the following. I can produce what others can produce, but not necessarily using the same way of production. There are so many ways of producing an item, not only one thing. And I told you, remember in my class example about cooking okra, for example, or green beans. Okay, we know the ingredients, we know the materials that are used in cooking, but remember, that doesn't mean that you have to use the same exact amounts of everything, because otherwise the food that is produced by one single mother will apply to all mothers in the world, which is impossible. We also have to assume that you can substitute resources for one another. Usually remember we said that the factors of production are labor and capital, and we usually say in economics that you can have a production system that is defined as labor intensive, which means that if you divide the amount of labor by the amount of capital, it will be more than 1. It means that you are using in your production methodology more labor than capital. Or you can have your production technology depends heavily on capital, which is machinery, equipment, and building, which means that the labor capital ratio, if you divide the amount of labor by the amount of capital, this percentage will be less than 1, which means that we are using a lot of labor but very few equipment. An example of that worldwide, for example, if you look at agriculture, because this is agricultural economics course, you know that Egypt, for example, Egyptian agriculture is characterized by being labor intensive. American agriculture is characterized by being capital intensive. And here, after that, we defined what is the production function, and we said that the production function is a physical or engineering relationship that tells you what will happen to the level of output when the level of inputs change. And by doing that, the production function embodies, it means it includes, it means it is within the definition of the production function, it means that it displays the technology that you are using in the production process. So the production function in general, it is a physical or engineering relationship that deals with transforming inputs to output. And I give you here, this is an example of a production function. Y is a function of x1, x2, x3, and x4. And as you can see here, all the x's here, here we have a long run production function. Why? Because there is here we did not assume that any inputs are fixed. Here we assume that all inputs are allowed to vary. Despite that, we will not use that in our course. Well, how did I know that? Because there is no, remember, there is no there is no straight line. So here, when we have the production function like that, this is okay. What is x here? X is a vector of all the x's that you have, which means that you have if you have capital X, it means that it includes x1, x2, x3, x4 all the way to xn. What are the types of inputs that we use in agricultural production? C is the fertilizers, labor, machinery, energy, water, nitrogen fertilizers, phosphate fertilizers, and all other types of fertilizers, pesticides, and so on. Okay? And then I ask you a question about can we increase all the inputs in the same proportion, and if that is possible or not. And as you can see in that graph, if you by doubling inputs you can double output, or by quadrupling inputs you can quadruple output, and so on, it means that you operate under the condition of constant returns to scale. It means that doubling inputs will double output, quadrupling inputs will quadruple, and so on. Okay, as you can see here, the production function is a function that is assumed to be linear, stemming from the origin, which means that if you use here the x's here, it stands for all the x's. Okay, and as we said before in our class, that it is impossible to have a production function that looks like that. TPP, or total physical product, this is another name for the production function. Okay, so here it says that here it means that according to that graph of the production function that you see on this slide, it means that you can produce infinite amount of output as long as you are using infinite amount of inputs. And we know that in reality this is impossible, because if things are like that in reality, then the world will have no problem at all, and we will never experience hunger or famine at all, because just use more inputs and you will get more output. But the real production function, as we will see in a moment, tells you that there is an end for everything. There is nothing like that in reality. This is a theoretical production function that doesn't exist in reality. Okay. After that, we defined, I told that our course will talk about productions here in the short run and in the long run. And we said here that the amounts of inputs that you cannot change their amounts because you don't have the time for that or the money for that, they are called fixed inputs. Usually they are the bulky stuff. Okay, I want to increase the size of my farm, I need time, I need money. I need to erect a building, I need time, I need money. I need to buy a tractor, I need time, I need money, and so on. The variable inputs, these are the types of inputs that I can change their amounts as a producer anytime I want, because it's so simple. I can hire a laborer anytime I want, I can increase the amount of labor in my farm anytime I want, I can buy fertilizers anytime I want, and so on. This is the true production function, remember? As I told you before, it displays, here this production function looks actually cubic function. And here, as you can see that, here I'm changing the amount of x1 which is the variable input, given that I have other fixed inputs, x2 all the way to xn. And the reason we have fixed inputs in addition to the variable input is that it is impossible in any production process it is impossible to produce any output while using one input only. It is impossible. You need, as I told you, remember the example I gave you in class, can you cook green beans by having green beans only? And the answer is impossible. You need other things. You need the water, you need salt, you need pepper, you need tomatoes, you need meat, you need ghee or butter, you need so many things. You need tomato paste and so many stories. So here we assume that x1 is the variable input and y is the level of output, given that x2 all the way to xn are fixed inputs. And as you can see here, as the amount of x1 increases, given that x2 all the way to xn remain constant, output increases at an increasing rate, and then output increases at a decreasing rate, and then output reaches a maximum. And then if you are crazy enough to continue adding that more of x1, then output will decline. We call that in economics diminishing returns. So as you can see here in this slide, the law of diminishing returns states that as more of the variable input is used while you have some fixed inputs used in production, total product, which is total physical product, okay, or TPP, or Y, or the level of production, or the volume of production, or the level of output, all that is the same, will increase and then reaches a maximum, and after that it will decline. And here it says rings a bell. It means that doesn't that remind you of the total utility function that we talked about before, which tells you simply that there is an end for everything in consumption theory and in production theory. After that, I told you before that the production function is an engineering relationship. People who study engineering at the College of Engineering next door, they study the production function. But what is new here in economics is that we derive things out of that production function that are of importance in economic analysis, which is the average physical product or APP of the variable input and the marginal physical product or MPP of the variable input. So if we say that we are producing a level of output called Y and we are using an amount of x1, which is the variable input, while we have fixed inputs x2 all the way to xn, which we do not care about in our work, we will have a production function that could be called Y or TPP, which is a function of the level of x1, given that the level of x2 all the way to xn are held constant. And here the average physical product of the variable input, which is called the APP of x1, is equal to the total amount of production divided by the amount of x1 used. Here APP, as I told you before and as I showed you in class, it shows the average contribution of the single unit of the variable input to the production process. How much the single unit of the variable input contributes in terms of production. And here the unit of measurement that is used in average physical product of x1 must be the unit of measurement used in measuring output. And I showed you that in class. For example, if TPP is measured in tons and x1 is measured in kilograms, then APP of x1 must be in tons. And remember, I proved that to you in class for the people who attend the lectures. And the same thing applies to the marginal physical product of the variable input. It is the rate of change in the level of output given with respect to the level of input. Okay, MPP of x1, it is equal to the delta TPP of TPP divided by delta x1, which means what will happen to the total level of production when the level of x1 it changes by 1 unit. And remember, MPP of x1, it is the slope of the production function. It is the marginal function. It is the rate of change of output with respect to the variable input. Okay, it is what happens to the level of output when the level of the variable input changes by 1 unit. It is the first derivative of the production function. All that applies to the MPP. And remember, all that, if you look at Shireen 7, I believe, I don't know if Shireen 7 or Shireen 8 or both combined, you will see all that written in great detail in my document. Shireen 7, Shireen _7, Shireen _8. And this is a table here that this is actually where we stopped the last time. This is a table that shows or displays the law of diminishing marginal returns. Okay, and here in that example we have variable input is assumed to start from 0 all the way to 10 units. We don't care about the unit of measurements here. any unit, kilogram, tons, bags, meters, whatever. I don't care about cubic meter, anything like that doesn't matter. Here we assume in our that a simple example is that when I use zero unit of x1, I produce zero output. This is for simplicity, despite that in reality it never happens. Why in reality it never happens? Because if we assume that x1 is water, for example, that the farmer is using to irrigate his or her crop, as you can see, even if I do not use water, some output will come. Why? Because some rain eventually will come out of heaven. So it is impossible that if I use 0x1, I get zero output. Usually you get some output. Okay, not the output that you want to get, the amount that you want to get, but you will get output anyway. So here it is done when we say that x1, if x1 is 0, we have total output is 0, just to simplify, to tell you that we are at the origin. If I use a 0 amount of the variable input, I will get nothing at all. And as a result, because I'm doing that, the average physical product of the variable input and the marginal physical product of the variable will not be defined. They are undefined. And that's why I put a hyphen. Okay? The reason I put a hyphen here, it means that they are undefined. They are not 0, remember. Why they are not 0? Because in order, remember, 0 divided, I want to calculate here, suppose that I want to calculate, look at the first number in the APP, the first number that I have here, for example. Look at the first number here that I have here. Okay? If I divide 0 by 0, 0 divided by 0 is undefined. It is not 0. And that's why we put it like that here. Okay? And the same thing applies to a marginal physical product, because in order for me to know a value right here, instead of this hyphen, I have to know what was beyond the 0. What was before output level equal to 0? What was before input level of 0? What was before that? And the answer is there is nothing, because I told you, remember before in economics we do not have negative variables. Remember that the minimum amount of x1 that I can use is 0 amount x1. I cannot use negative x1. And the minimum amount of output that I can produce is 0 output. It cannot be less than 0, because there is no negative. And as a result, you can see a hyphen here and a hyphen here, which means that the APP of the variable input and the MPP of the rate are undefined. Now, if I increase the level of the variable input to 1, the level of output goes from 0 to 12. And if I increase the level of the variable input from 1 to 2, the total production increases from 12 to 30. And then if I increase the level of the variable input from 2 to 3, then the level of output increases from 30 to 44, and the story continues like that all the way up. Okay, if you go here, if you see here, as you can see, maximum output here is 74 units. Okay, maximum output here is 34 units. And this is okay, I cannot see it. Let me put something in green. Okay, this is the maximum output that you can get. Okay, 74. After that, after that, as you can see, this is the maximum output that you can see. And as you can see that if I continue using the variable input in units beyond 8, as you can see here, the level of output starts to decline. Okay? Definitely when it starts to decline, there is no need to continue the table and to show you anything beyond the 10 units, because the guy, the farmer, the producer, the individual producer saw that when he or she used the 8 units of the variable input, the maximum output he got. After that, he found that output is declining. So why he will continue, even if the input is for free. X1 is for free. I do not pay any money. Why should I use it to reduce the level of output? Okay. So this is what's in here. As you can see, how do we calculate that? How do we calculate this? Now we are done with that. These numbers are given to you. These are hypothetical. Okay. And this, why it is hypothetical? It is hypothetical, but reflects the classical or what they call the new classical production function. Remember that the word classical, it means that the thing that we see most of the time. Okay, as I told you, a classical person is a person that is a typical person. Yeah. A typical person that has two arms, two legs, a trunk, a body, yani, and it has a head, and the head contains two eyes, one nose, two ears, and one mouth. This is a classical person. Okay, and that's why also these numbers are hypothetical, just to reflect to you the graph that you saw before about the production function, that it is increasing at an increasing that goes like this. If I want to graph it, the production function looks like this. Okay, that's why he's having the numbers like this, to make you see a function like that. Okay, now the question is, how do we calculate? So now these numbers are given. The question now is how to calculate APP of the variable input. Okay, now I told you here, we know that it's already, as you can see, it is already here undefined and undefined. Okay, what about this number? How do we get this number here? This number is, you divide 12 divided by 1. 12 divided by 1 is equal to 12. 30 divided by 2, 15. 44 divided by 3, 14.7. 54 divided by 4, 13.5, and so on. Okay. Now, if I want to tell you, for example, what is 12.4, explain to me the meaning of 12.4 that is right here. Okay. It means that if I use 5 units of the variable input, which is right here, which allowed me to produce 62 units of output, it means that the 12.4 is the average contribution of the single unit of the variable input. Okay? Remember, if you multiply 12.4 by 5, you will get 62. So if you divide 62 by 5, it means that the average contribution of the single unit of the variable input is 12.4 units. And remember, the units of measurements here, if this one is in tons, then this one is in tons, and this one is in tons as well. Okay? All these units for column 2 and 3 and 4 are measured in the units that are used in measuring the level of output. So now we know how do we calculate the APP. Now let us see how do we calculate the MPP. Okay. Now I told you here we put hyphen here and hyphen here. After that, I want to know how do we get this 12 right here. This 12 right here is 12. It is actually 12 minus 0 divided by 1 minus 0. So 12 minus 0 divided by 1 minus 0 is equal to 12. I put it right here. What about this 18 right here? This 18 right here is 30 minus 12 divided by 2 minus 1. What about this 14? This 14 is 44 minus 30 divided by 3 minus 2. What about this 4 right here? This 4 right here is 72 minus 68 divided by 7 minus 6, and so on. And as you can see, here APP cannot be negative or 0, but MPP can be negative and can be 0. Where is the 0 here? Is somewhere here between this 2 and minus 2. Okay, but remember here we don't have a smooth function. We have discrete function, broken lines, a function that is composed of broken lines. And as I told you in one of the homeworks, please go to the homework and please graph this table. In order for you to graph this table the easy way, please put x1 measured horizontally and the TPP measured vertically. Okay, and graph that only. Okay, you have the first point is 0 and 0. The second point is 1 and 12. The third point is 2 and 30. The fourth point is 3 and 44. The fourth point is 4 and 54. The fifth point is 5 and 62, all the way till the end. Connect the points. Definitely the production function will be broken lines. It will not be smooth. But why do we do that? Because we cannot graph a smooth function, because graphing a smooth function requires an infinite number of the values of x1, an infinite number of the values of y or TPP accordingly. We do not have infinite numbers, but this is for practice. Now I want you, after you finish graphing the production function where you put x1 horizontally and y vertically, I want you to make another graph. In the other graph, you're going to put x1 horizontally, while APP of x1 and the MAPP of x1, both of them at the same time measured vertically. First of all, you need to measure, to graph this one. How do we graph the APP? Okay, when x1 is 0, this one is undefined, so there is nothing at 0. When x1 is 1, this one is 12. When x2 is 2, APP is 15. When x1 is 3, APP is 14.7, and so on. Connect the points. You will have an APP function. Likewise, you will do the same thing for MPP if when you graph it. When x1 equal to 0, undefined, so you cannot do anything about it. When x1 is equal to 1, then x2 is MPP is equal to 12, and when x2 is equal to when x1 is equal to 1, MPP is equal to 12. This is the first point, 1 and 12, and then 2 and 18, and then 3 and 14, and then 4 and 10, and then 5 and 8, and then 6 and 6, and then 7 and 4, and then 8 and 2, and then 9 and the minus 2, and then 10 and the minus 4. Connect to the point, you'll see something that looks like the production function. Remember, I gave you very nice graphing in the document that I uploaded recently that talks about the accurate graphing. Okay, now we are done with that graph. Okay, this table, you need to practice graphing it because it will teach you a lot. Okay. And if you go home and you do that homework, you will end up having the production function. Here he made the 3 functions on the same graph. Okay, the blue line, this is the production function or the total physical product function. The pink line is the average physical product of x1 function, and the yellow line is the marginal physical product of the variable input function. Okay, marginal physical product of x1. Okay, and all of them are functions. Functions of what? Okay, all of them are functions of the level of the variable input. Yani TPP is a function of x1. APP is a function of APP of x1 is a function of the level of x1. MPP of x1 is another function of x1. Okay. So when you go home, but the reason I told you to make them in 2 separate graphs because in order for you to do the scaling correctly, it will be a little hard. But if you put them all on the same graph, they are correct. It is correct to put them all on the same graph. The total physical product function, the marginal physical product function, and average physical product function. Why? Because all of them will be right here. All of them will be right here, and the level of x1 will be right here. So that way, and all of them are here. They are using the same units of measurements. And this is actually the smooth graphing. This is what I told you. You will get, of course, definitely you will not get a smooth function like that, or a smooth function like this, or a smooth function like that. And the reason you don't have infinite number of points. Okay, please, the inflection point here, as you can see. Now we want to know the remarks that we should realize when we do that graphing. Okay, the remarks, as I told you, actually they are written in the slide that will follow. He will tell you that. Please note that. Remember here, this is the level of the variable input. Okay, and this is the level of output. Okay, here they tell you that the more you use the variable input, output first of all increases at an increasing rate, and then increases at decreasing. This one graph, that's why I don't like it here. It's not graphed correctly because this one is claimed to be an inflection point, but actually the way it is graphed doesn't look like an inflection point. And that's why I told you to refer to the chapter that I uploaded lately about the correct graphing of this one, because this part right here should look something like this. Okay, and this will be the inflection point, but it doesn't look correct here because all of them, they look the same. But anyway, the inflection point corresponds to the level of x1 where MPP of x1 is the highest, as you can see here. Okay, right here. And then after that, this is the part where the function increases at an increasing rate, right here. Okay, after that, after the level of x1 makes the MPP of x1 reaches its maximum, after that, the more you use x1, then output will start to increase at a decreasing rate, which means that MPP will start declining all the way down to 0 and negative. Okay, that's if you are crazy enough to continue using x1. So here, here, as you can see, uh, after the inflection point, here before the inflection point output increases at an increasing rate, and then after the inflection point output increases at a decreasing rate all the way till it becomes maximum. When the total physical product is maximum, then the marginal physical product of the variable input is 0. Okay? And when MPP after the inflection point, remember before the inflection point, MPP is increasing at a decreasing rate. After the inflection point, MPP is decreasing all the way. Now, for the average physical product, the average physical product increases at a decreasing rate, reaches a maximum, and then declines. But it's never 0, it's never negative. When APP of the variable input is at its maximum, it is equal to MPP, which means that MPP penetrates or hits or touches or crosses the APP curve at the maximum of the APP. Okay? Now we want to define something that is, they call it the 3 stages of production. What is the 3 stages of production? Okay, they tell you that in stage one starts from 0 variable input all the way to this point. This is stage 1. In stage 1, they tell you there is no economics. As long as you are having 1 variable input, please keep using more of it. Okay, remember here we did not introduce any money yet. There is no money in the story. Okay, so assume that everything is for free. Yani I get X1 for free. Okay, they tell you that whether you get it for free or for money, please keep using X1 all the way from here to here. No thinking. Why there is no thinking? Because output keeps increasing at an increasing rate here, and then increase at a decreasing rate till you reach this point. Okay? This point right here, remember before that, the reason this part is in the stage 1, despite that, after the inflection point, output starts to increase at a decreasing rate is because marginal physical product of the variable input is above average physical product of the variable input. You see in this part, right here, we have always the marginal physical product function is above the average physical product function. And that's why even despite that after the inflection point, output starts to increase at a decreasing rate, we still have to use more of X1 without thinking. There is no thinking here. Now let us go to stage 3, which is right here. Stage 3, which is right here. In stage 3, remember, you reach this point. Here they tell you that there is no rational producer at all that is operating in stage 3. It means that, for example, that the farmer keeps on adding the fertilizer to kill the plant. It is impossible. Okay, so nobody operates here. So that's why we say that stage 1 and stage 3 are 2 irrational stages of production. And the only stage where there is economics, okay, in it is stage 2. What does it mean there is economics in it? It means that somewhere in stage 2, you have to use the amount of X1 that will maximize your net returns or net revenue. Somewhere. And surprisingly, that somewhere in stage 2 can never be on the borders. Yani, this border here, this amount of X1 right here cannot be the profit maximizing level of X1 or the net revenue maximizing level of X1, and this point right here can never be the net revenue or the profit maximizing level of X1. Without going into whys, it has to be somewhere in here, in this part within these borders right here, but never on the border. This is where the economics is. In order for me, remember what are we trying to reach here in our story? We are trying to reach how much of X1 I, as an individual producer, should use to maximize my profit or net revenue, as you will see later on. In order for me to decide exactly where here exactly, how much exactly of X1 I'm going to be using, I have to know the unit price of X1 and the unit price of output. Because based on the relationship between the unit price of the variable input and the unit price of output, I will be able to determine an optimality condition that tells me what to do. And as you will see later, inshallah, the optimality condition will tell you that use the level of the variable input at which the value of marginal product of the variable input is equal to the unit price of the variable input. This is the rule, the optimality rule that we will see later on. The value of marginal product of the variable input is the multiplication, is the outcome of multiplying the marginal physical product of the variable input by the unit price of output. Okay, so another way of stating the optimality condition is that use the level of x1 at which MPP of x1 is equal to P of x1 divided by P of y. Okay, this is another way of stating the optimality condition. Use the level of x1 to the level till you reach the level where the marginal physical product of x1 is equal to the price ratio of, which is the price ratio of the unit price of the variable input divided by the unit price of output. Okay. These are the notes, as you can see, the important notes on physical curves. This is when MPP is increasing, TPP is decreasing. That's all what I explained in my notes. There is nothing here about it. I just explained that on the graph. And this is the 3 stages of production, which I already told you what they are. And if you look at the graph and given what I said, okay. Next, this will be the end of the class. Inshallah, I'm gonna upload this to you first, and then I'm gonna start next time from when we introduce money. In our next class, inshallah, we'll have, suppose what the story will look like when we have money in the story. Remember, in our previous story, we assumed that there is no unit price of x1 and there is no unit price of y. Okay, and with the absence of money, this is how things will look like. Now, in our next class and our next uploaded PowerPoint, we're gonna see. Now we know that inputs are not there for free and outputs are not sold for free. What the story will look like when we have money. This is the end of the class. See you next time.